All right, in this section, we're going to look at number 23 for each position vector given. So we're looking at number 23 for that one. We're going to graph the vector, name the quadrant for part A, then compute its magnitude for part B, and C, find the acute angle formed by the vector in the nearest x-axis. So let's start with a coordinate plane. So let me get some straight lines up here for a y-axis and an x-axis. And then I have starting at the origin, I can do the position vector. So that's -2, 1, 2 is the vertical component. And the horizontal component is -5. Oh, sorry, switch it all around. Horizontal is -2, vertical is -5. So that's down 5. 1, 2, 3, 4, 5. So that means I have a vector that starts at the origin and ends at 2, 5. -2, -5. So that's the position vector that's named by its components. So that is part A. And then let's do part B in green. Part B says compute the magnitude. So the magnitude would be the length of that vector, so I can think of this as the Pythagorean theorem. And that magnitude, so I'm going to write the name of the vector between two absolute value bars. That's just its name. That equals square root of the horizontal component, which is -2 squared, plus the vertical component, which is -5 squared, which equals the square root of 4 plus 25, or square root of 29, which does not have any common factors, so that is already reduced. And let's see, that is part B. And then C. In C, we're looking for that acute angle. So this angle, the nearest x-axis in the vector. So that's like the reference angle from previous units. So I'll call that theta r. And that angle I can find using tangent. So so I can look at this triangle that's being formed here with the x-axis and treat that like a right triangle. The horizontal component was -2, so that length is 2. The vertical component was -5, so this length over here is 5. So if I think about SOHCAHTOA, then I know that tangent of theta r is opposite over adjacent, which is 5/2. So theta r equals, taking the tangent of both sides, is this. And if I put that into my calculator, I will get approximately 68.2 degrees. And notice that this matches up with our formula that's given us in the text, which is that reference angle is equal to the inverse tan of the absolute value of the the vertical component over the horizontal component. So I took the absolute value because I want this little angle, so I'm treating it like an acute triangle.